How's it, grade 11s? Today we're going on to trigonometric functions and identities. I'm working from this chapter in your book here. Okay, so just a couple of things that I want you guys to take down is, if you remember your definitions, sine theta is equal to y over r, cos theta is equal to x over r, and tan theta is equal to y over x. Now just remember where that's coming from. It just means that for any angle we can break it down into an x, y, and r component. Okay. Now there's a silly little rhyme that we can use to remember this. It's shelter your rear because x-rays tan your exterior. Okay. Then what we've got is we've got reciprocals. Now reciprocal just means the opposite. So cosec is r over y, which you can see is the opposite of sine, y over r. Okay. Then we have sec theta, which is the reciprocal for cos, r over x, and cos is x over r. And then the reciprocal for tan is cot. We have y over x and then x over y. So what this actually means, it means that cosec will be equal to 1 over sine, sec will be equal to 1 over cos, and cot will be equal to 1 over tan. Then we have our quotient identities, which is tan theta is equal to sine over cos, and cot theta is equal to cos over sine. Now this is important, guys, because what I want you to do is change everything to sine and cos, which you'll see with some of the examples that we go through. Then our square identities, we have sine squared theta plus cos squared theta equals 1. Now this one here is the one that you're going to be using the majority of the time. Okay. The reason why, because you'll see with the other two now, we have 1 plus tan squared equals sec squared. You remember what I told you? Change everything to sine and cos, and we'll get back to this one anyway. Last one, 1 plus cot squared is equal to cosec squared theta. Again, change everything to sine and cos, and you'll get back to that one there. All right, so let's go on to an example. We've got example 1a. The question is, simplify the following expressions into one trigonometric ratio where possible. So first question, sec theta minus sec theta multiplied by sine squared theta. Okay. Now, before I start changing everything to sine and cos, I can see I have a common factor here of sec theta. So I'm going to be taking that out as a common factor, and we get sec theta 1 minus sine squared theta. Okay. Now I'm going to change everything to sine and cos. So you can see that sec theta is equal to 1 over cos. All right. So that's what I'm going to change the sec to. So this becomes 1 over cos theta. Now this one over here, I'm going to use my square identity over here. All right, just going to write it on the side here. So we have sine squared theta plus cos squared theta is equal to 1. Now, I know we don't have that exactly over here, but what I can do is I can manipulate this so I can get this. So if I take the sine to the other side, the sine squared, what we'll get is we'll get cos squared theta is equal to 1 minus sine squared theta. Okay, and that is exactly what I'm going to change here. I'm going to change the sine 1 minus sine squared, which is 1 minus squared, to be cos squared theta. So this becomes cos squared theta. This cos will cancel with one of those coses, and we just left with cos theta. Okay, and that's our final answer for that one. Then example B. We've got sec squared theta times sine squared theta minus sec squared theta. Okay, again, grade 11s, I've got a common factor of sec squared theta. Take it out as a common factor, and we're left with sec squared theta into sine squared theta minus 1. Okay, the sec squared, as you can see from over here, I am now going to change the sec squared to 1 over cos squared. Okay, like I said, I just want to bring this to your attention. We can use the square identity to be 1 plus tan squared. But you're just going to make your lives a misery, grade 11s, because now you're introducing this one, and then that one you're going to have to change the sine and cos. What I would do is just go straight into it. Sec squared is equal to 1 over cos squared, and you've got everything in terms of sine and cos. Okay, so this becomes 1 over cos squared theta. Now this one over here, again, I am going to manipulate my square identity. So we have sine squared theta plus cos squared theta equals 1. That's our square identity. Now I'm looking for sine squared theta minus 1. So I need to take the 1 to this side and the cos to that side. So we get sine squared theta minus 1 is equal to cos squared theta. So there is my sine squared theta minus 1, sine squared theta minus 1. And I'm going to replace it, sorry, not cos squared, but minus cos squared, because I take it to the other side. I'm going to replace that with minus cos squared theta. Okay. As you can see, the cos squared here will cancel with the cos squared over there, and we're just left with 1 times minus 1, which is minus 1. And that's our final answer for that one. Moving on to example C. We've got tan squared theta multiplied by cos squared theta plus cot squared theta multiplied by sine squared theta. Okay, so what I'm going to do here is I'm going to change everything to sine and cos. So you can see here that tan squared, or tan rather, tan is sine over cos, but if we had to square this to be tan squared, it would just be sine squared over cos squared. And that's what I'm going to change that one to. So this becomes sine squared theta over cos squared theta. This is already cos, so I'm happy with that. So that's times by cos squared theta plus our cot squared, we are going to change to cos over sine. But because it's squared, cot squared, it's going to be cos squared theta over sine squared theta. So this one will become cos squared theta over sine squared theta multiplied by sine squared theta. All right, so this cos squared will cancel with that cos squared, and we're left with sine squared theta plus this sine squared will cancel with that sine squared, and we're left with cos squared theta. Now, that is our square identity. Sine squared theta plus cos squared theta. And we know that's going to be equal to 1. All right, example D. We've got tan theta plus cos theta over 1 plus sine theta. Okay, so we're going to change everything to sine and cos, and we know that tan is equal to sine over cos theta. So that becomes sine theta over cos theta plus cos theta over 1 plus sine theta. All right, grade 11. So you remember when you're adding and subtracting fractions, we need to find an LCD. So our LCD here will be cos theta multiplied by 1 plus sine theta. So we'll have cos theta multiplied by 1 plus sine theta. Okay, now we need to multiply this by this, so we need to multiply by the top. So I'm just going to miss one step, grade 11s. I'm just going to multiply inside with this one. So that and that will give us sine theta. Sine theta times sine theta will give us plus sine squared theta. Plus, that needs to be multiplied by that, so we need to multiply the top by that. So cos times cos is cos squared theta. Okay. Now, if over here I have a sine squared theta plus a cos squared theta, and I know that's going to be equal to 1 from our square identity. So we get sine theta plus 1 from that, all over cos theta multiplied by 1 plus sine theta. Now this entire 1 plus sine theta will cancel with the sine theta plus 1, and we are left with 1 over cos theta. And I know that 1 over cos theta is going to be equal to sec theta. Okay, grade 11s, what I would like you to do for homework is just on the next page. So it's on page 79. Can you guys just do number 1 for me now, please? Thank you.